Hello friends, welcome back in Tech-Tied Digital Lifestyle for main switchboard MSB tutorial lecture. Today very important lecture part of tutorials series is air circuit breaker ACB. On the screen, you can see a large air circuit breaker installed inside a marine main switchboard. This is one of the most important. An air circuit breaker, or ACB, is a low-voltage high-current breaker used to protect generators, bus bars, and main distribution systems. It is called air circuit breaker because the arc formed during tripping is extinguished in air at atmospheric pressure. In ships, ACBs are normally used as generator breaker, bus tie breaker, main incomer breaker, emergency switchboard breaker. ACB is the guardian of the switchboard. If a short circuit or overload occurs, it reacts instantly and isolates the fault. Without ACB, a simple short circuit could damage generators, burn bus bars, or cause complete blackout. Understanding ACB is not optional for marine engineers or ETOS. It is essential knowledge for oral exams, interviews, and real onboard situations. Today, we will understand external parts, internal components, working principle, protection functions, common defects, troubleshooting, maintenance. Let us now move to its applications on board. Applications of ACB on board. Here you can see different ACBs inside a switchboard labeled as generator breaker, bus tie breaker, shore connection, and emergency breaker. Each ACB has a different responsibility. Generator ACB connects the generator to the main bus bar after synchronization. It must handle full generator load and fault current. Bus tie ACB connects two bus sections. During maintenance or fault isolation, bus tie allows flexible power distribution. Shore connection ACB connects external shore supply to ship system when in port. Emergency switchboard ACB protects emergency generator output. All these breakers look similar but their protection settings may differ depending on rating and function. Interlocks are also provided. For example, shore supply and generator cannot be connected together without proper synchronization. Understanding where ACB is used helps you understand its importance in system stability and protection. Main external parts of ACB. On this slide, you see the external view of the air circuit breaker. Let us understand each visible part. Closing button used to close the breaker manually. Trip button used to open the breaker manually. Charging handle used to manually charge the closing spring. Indication window shows breaker status, on, off, tripped. Terminal connections where power cables connect. Racking mechanism used in draw-out type ACB to move breaker from service to test or isolated position. These external parts allow operator interaction. Always check the indication window before operation. Never assume breaker position. Draw-out ACBs allow safe maintenance because they can be removed from bus bar without disconnecting cables. Understanding external parts is the first step before going deeper inside. Internal components of ACB. Now we see the internal structure using a cutaway view. Inside the breaker, fixed and moving contacts, these carry current. Arc chute located above contacts, extinguishes arc. Arc splitter plates divide arc into smaller segments to cool and extinguish it. Closing spring stores mechanical energy for fast closing. Trip latch holds mechanism in closed position until trip signal. Shunt trip coil electrically trips breaker when energized. Under voltage release, UVR, trips breaker if control voltage drops. Auxiliary contacts provide status signal to control circuits. When breaker trips, moving contact separates from fixed contact. An arc forms due to high current. That arc is guided upward into arc chute where it is split and cooled until extinguished. This happens in milliseconds. The arc chute is a critical safety component. If damaged, breaker may fail during fault. This is why internal inspection is important during maintenance. Working principle of ACB. Now let us understand step-by-step operation. Step 1. Spring charging, either manually or motorized. The closing spring is charged. Step 2. Closing command. When close button is pressed, stored energy releases. Step 3. Contacts close, moving contact connects to fixed contact, allowing current flow. Step 4. Normal operation, current flows safely through breaker. Step 5. Fault occurs, protection system detects overload, a short circuit. Step 6. Trip signal, trip coil activates. Step 7. Contact separation, trip latch releases, contacts separate instantly. Step 8. Arc formation, arc forms due to current interruption. Step 9, arc extinguished. Arc moves into arc chute and gets extinguished. This entire process is extremely fast. ACB is designed to interrupt very high fault currents safely. Understanding this sequence helps in troubleshooting. Protection functions in ACB. Modern ACBs have electronic trip units. Common protections include long-time overcurrent protection for overload conditions, short-circuit instantaneous protection for very high fault currents. Short delay protection provides coordination between breakers. Earth fault protection detects leakage current to earth. Under voltage protection trips breaker if control voltage fails. Protection settings are adjustable. Improper settings can cause nuisance tripping or failure to trip. Always follow manufacturer manual and ship electrical coordination study. Protection is the brain of ACB. Mechanical parts execute the command, but electronic unit decides when to trip. Common defects in ACB. Common onboard problems include breaker not closing, possibly spring not charged, UVR not energized, or protection active. Breaker not tripping, trip coil failure or mechanical latch jammed. Spring not charging, motor failure or mechanical issue. Frequent nuisance tripping, wrong protection settings or faulty CT. Contact erosion due to repeated heavy faults. Overheating terminals, loose connections. Burning smell, possible internal damage. Regular inspection prevents major failures. Never ignore minor abnormal signs. ACB failure during fault can be extremely dangerous. ACB troubleshooting guide. If breaker not closing, check spring charged indicator. Check control power supply. Check UVR energized. Check protection relay reset. If breaker not tripping, check shunt trip coil. Check relay output signal. Check mechanical latch movement. Always troubleshoot logically. Do not bypass UVR permanently. Do not disable protection to keep system running. Safety must not be compromised. Step-by-step diagnosis prevents repeated failures. ACB maintenance or inspection. Maintenance should follow PMS schedule. Visual inspection, check dust, cracks, loose parts. Contact inspection, check wear and pitting. Arc chute cleaning, remove carbon deposits. Terminal tightening, prevent overheating. UVR testing, ensure proper tripping on voltage failure. Trip coil testing, verify electrical trip function. Insulation resistance test, ensure proper insulation. Functional trip test, confirm real operation. Maintenance increases life of breaker and ensures safety during fault. Never skip testing procedures. Final summary or professional importance. Today we covered external parts, internal components, working principle, protection functions, common defects, troubleshooting, maintenance. Air circuit breaker is the backbone of switchboard protection. Understanding ACB makes you confident during blackout, short circuit, or emergency conditions. This topic is frequently asked in marine oral exams and interviews. A good engineer must not only operate ACB, but understand it completely. Knowledge gives confidence. Confidence improves safety. Safety protects lives and equipment. Thank you for watching this complete masterclass on air circuit breaker. This lecture completes our full switchboard and power system tutorial series. If you found this video useful, please like, share, and comment below. Subscribe to TechTide Digital Lifestyle and explore our playlist section for complete important marine and industrial electrical tutorials. Continuous learning builds professional excellence. Stay safe on board, keep learning, and I will see you in the next advanced technical session. Thank you.